Hello, welcome everyone to question number 10, symmetric tree from the topic trees of Geek for Geeks mostly to coding interview questions. Have a quick look at the question and we'll be discussing the approach and the meaning behind the question. Before that, please don't forget to subscribe our channel, and if you have any extra email IDs, please do subscribe. That will be very helpful for our growth of the channel. And if you have any doubt, just leave a comment below. Now coming to the meaning of the question, here we got a input named 51122 tree here. So what we're going to do is the question is saying that there is a tree and we have to find out if the opposite side of it is same or not. Okay. By symmetric tree, you can assume if you take a number and if you reflect inside the mirror, okay, it will show the opposite side of that, right? Similarly, if you take a mirror here in between, now you can see one is on the left and one is on the right, two is on the left, two is on the right. But for the root element, it is only one element in the middle, so we won't take the root element case. You take other left side and right side cases only. So if you observe carefully, 1 and 1, 2 and 2 are reflecting perfectly to each other. So this is the meaning of a symmetric key if the opposite side should be the same value. Okay, so this is the meaning of symmetric tree. Opposite subtree should be same. Okay, now how can we approach inside the coding part is we have to take a empty stack and call it st, and in this st we have to insert two variables at the initial stage. That would be root dot left element and root dot right element. That would be this one, the root dot left, and this one which will be root dot right. Okay, now we have initialized by adding those elements inside a stack. After adding those elements, we will be using this while loop that I have mentioned here, and there are four conditions inside that while loop which we have to follow through. Now we will also be doing a dry run of the right side while loop. Okay, now n1 is the element which we popped. Okay, the first pop will get the rightmost element, which is 1 in this case, and again we are also popping second time. That will be n2, which will also be 1 here, and the stack will be empty. Okay, we pop two times and stack is empty here. Now we will be checking the condition. The both n1 and n2 should be none. Okay, if they both are none, then we continue to a while loop. If it isn't, then we go to the next condition. N1 or N2 is none. N1 and N2 are not none. Okay, these have some values, and remember N1 N2 are addresses which are indicating to the data and 1 here. Okay, while we are explaining, we are taking data which will be easier to understand, but here you must assume that this is the address of the data n1 and n2. Okay, at that address we have this data 1 and 1. Okay, I hope you have understood till the second part here. Coming to the third condition is checking the data is equal or not. If it is not equal, then we return false here. Okay, that means the mirror image is not the same as the left side one. So in that case, we return false. Here, third condition also not valid. Now going to the fourth condition, it says we have to append n1 dot left, then we have to append n2 dot right. And remember, these are the mirror images of each other. These two will be the mirror images of each other, and these two will be the mirror images of each other. Now check the example n1 dot left. Okay, n1 we have 1. Okay, which is this left side one. For this one we are saying n1 dot left, for that will be the this child element, the 2. Okay, now that 2 will be added to the stack here. Similarly, the opposite of this is right side 2, right? So right side 2 is inside the right side of the n2 element. Okay, this 2 is the right side child of n2. So that's why the second line is n2 dot right. Okay, now we also show the 2 again here. Okay, now we will be storing the n1 dot right and n2 dot left similarly. Now this left element is finished and the right element is finished. Now there are two more elements remaining, right? Which will be this one, the right side of the left subtree and left of the right subtree. We're going to add them. If there is no element, then the address will be a none address or null address, you can see. And I'm representing that with n here. Okay, I'm representing null address with n element here. Okay, and this is the stack we got after the first iteration in the while loop. Okay, now the second iteration. Now this loop has been completed. Now stack is not empty, so while loop will accept the condition and it will repeat the same steps here. Now n1 will be 2 here and n2 will be 2 here. Now inside the stack what we have? Inside the stack there are two none elements here because there are no elements, so address of this element is none. So there are two elements now, which is fine. This will be equal to stack. And now let's do the condition same. Okay. For 1, 1, 2, these three conditions have been not satisfied. Similarly, for 2 and 2, these three condition will not be satisfied. Again, we'll be entering the fourth condition here directly. Now, what will happen is it will also check the child elements of this current data 2 and 2. These child elements will also be checked. How many child elements are there? For this 2, we have two child elements, and for this 2, we also have two child elements, and that are represented by n1 dot left, n2 dot right, n1 dot right. Okay, now we have to be careful which element is being added. Okay, and you can check this condition for that. Okay, the answer will be same whether we take left right, right left, which is four none elements will be added here. Okay, in total now at the last we have six none elements, and this will be our new stack. Okay, it will go to the while condition. It will check the stack is empty or not. No, the stack is not empty. So it will again pop. This time what happens is in this iteration, the third iteration, n1, n2 are none elements, and there is a condition here. If both n1 and n2 are none, we will be going to the loop again. We start from the start again. So what happens is now there are four ends remaining inside the ST. ST has four ends here. Okay, you have to make the list here. I'm just explaining for simplicity here. Now four ends are remaining. Now it will go to the continue statement again. 2n will be remaining. In this we have in the next iteration 2n's are there, and again in the fifth iteration again 2n's are popped out. Now 0n's are remaining. Now this stack is empty. Okay, now 6n's which were there earlier have been removed using the first condition here. Now the stack is empty. So we will be coming out of the loop. So after coming out of the loop, we can successfully say that there is no element remaining and it is a symmetric tree. So this while condition is being executed to know if the symmetric tree or not. I hope you have understood the logic behind the question and also know the meaning of the symmetric tree. If you still haven't understood, let's go to the coding page, and I hope after seeing the code, every doubt will be clear. Now we are inside the coding page here, and you can see the same thing has been executed here. Now we are checking if the root is none or not. Okay. Now if the root is none, then we return true. And here we take an empty stack to add our elements and use in the while loop here. And here we have taken dot left dot right. We added two elements from the tree, which will be this one and this one, which we already have discussed in the presentation. And this is the while loop that we have already discussed. Okay, and you just compile this code or submit it, it will definitely work. If you have any doubts even after seeing the code and executing it, just comment below where you're facing the problem. We'll be very quick to respond. And finally, please don't forget to subscribe our channel. That will be very helpful for the growth of this channel. I recommend if you have any extra mail IDs, please use those IDs and subscribe. Thank you for watching till then. Let's meet in another question.